Hello, everyone, and welcome to the International Biochar Initiative webinar. Today, we're going to be discussing biochar use in capping abandoned oil and gas wells. My name is Caroline Pete, and I will be facilitating this webinar. Before we get started, just a bit of housekeeping. You should already be able to hear me and see the share screen. If you're hearing echoes or your sound quality is bad, use the audio functions in the GoToWebinar toolbar, which is probably on the right side of your screen. If you're still having any trouble, send the organizers a message using the chat feature. And don't worry, we are recording this webinar. The recording and as well as the slides will be sent to you within a couple of days here, and they will also be posted on the members portion of the IBI website. If you are a member, you can access all past webinars there. If you have a question, you can ask questions at any time. We will be taking all questions with our panelists at the end of our presentation today. So with that, I am going to hand things off to our moderator, Kathleen Draper, to lead you through our presentation today. Kathleen, please take it away.
Thanks very much, Caroline, and good morning, good afternoon, and good evening, everyone, and thanks for joining us today to learn all about using biochar to cap old oil and gas wells. The topic of today's webinar is one that I first mused about back in December 2020 in a blog post entitled From Wildcatter to Carbon Capper. I wrote this after reading an article about using carbon credits related to methane reduction to help finance capping abandoned oil wells. Never did I imagine connecting and collaborating with folks to turn my ramblings into reality, but that's what happened. But before we dive into the topic, I always like to provide a bit of background on the International Biochar Initiative for those joining us for the first time, and there are quite a number of them. IBI is more committed than ever to helping the biochar industry scale in a sustainable manner. As many of you know, since you responded to our recent survey, we are nearing the end of creating a new strategic plan for IBI, which will provide a glide path for how we support the industry over the next 2 to 3 years. For those of you that did not yet respond and would like to provide input to the strategic plan, please feel free to reach out over the next week or so. Our focus areas will be expanding, hopefully, beyond our traditional areas of education and standards to include some level of demonstrations, more case studies, some research, and ensuring IBI's financial sustainability by expanding and diversifying revenue streams. More on this topic in the very near future. Next slide. The very generous grant we received last year from the WOCA Foundation is enabling us to grow our staff, and this month that includes our brand new communications director, Wendy Lou McGill. I was hoping that Wendy Lou could join us today to say a few words, but she's actually in transit coming to visit me in upstate New York. She may, in fact, arrive before this webinar is over, but she will at least be joining us for next month's webinar. We'd also like to give a shout out to the growing number of sustaining business and organizational members. Since last month's webinar, we've welcomed 17 new and renewing sustaining business and organizational members, which are listed here. As always, your confidence and support of IBI is critical to helping us scale the industry. Next slide. Back to the topic of today's webinar and our speakers. As the world has leaned so heavily on fossil fuels to energize our world, drilling sites number in the tens of millions, if not more. Many of those wells, estimated at close to 30 million, have been exhausted and abandoned without properly being capped. Improperly or uncapped wells are estimated to emit 2.5 million tons of methane each year. Due to methane's outsized impact on climate change, there is an increased urgency to reduce these emissions drastically and rapidly. Using biochar in this process can not only sequester carbon, but can provide some significant co-benefits. But I'll let our speakers provide more on that. I have no doubt that some in the biochar world may wonder if using biochar to cap oil wells is a form of greenwashing. But the reality is that those wells need capping, and fast. They are already being viewed as potential reservoirs for other sequestration options, such as direct air capture and even bio oil storage. The advantage biochar has at the moment, anyway, is that it's shovel ready. it's more affordable, and it could potentially utilize locally available waste feedstocks that may not make ideal biochar for agricultural soils. To tell you more about how this works is Mark Mersman, a co-founder of OFX Solutions. Mark will outline the process, climate and environmental benefits, as well as future possibilities for using biochar within the oil and gas and mining industries. I will note that this is still a very new market for biochar, though I expect, or at least I hope, it could grow quickly. Mark and his team are working out many of the logistics, costs, and benefits, and may not be able to share every detail. Also, as with any commercial entity, some of the details are proprietary, but I'm really glad he's willing to explain this opportunity to a broader audience so that others might start considering following suit. Next slide. Joining Mark is Barry Salisbury, CEO of Crew Energy. He is a veteran of the fossil fuel industry, and he's now focused on dealing with abandoned oil wells in Louisiana. And he currently serves as the chair of the Advisory Commission for Louisiana's Energy, Environment, and Restoration. Guys, I'll turn it over to you now, and then we'll take questions at the end.
Thank you, Kathleen. Hello, everybody. Thank you for joining us. Excited to have Barry Salisbury with us to provide a really exceptional insight into the funding and just the operations that the oil and gas industry go through as it relates to plugging oil and gas wells. And we're excited to share about how biochar can help reduce the carbon intensity and where we think this all can go. We are effectively developing carbon offsets, or have the potential to, as Kathleen alluded to. This is all very new, but there are multiple ways that we see approaching the remediation aspect of plugging these oil and gas wells, and even the mines. We don't talk about that so much in this, but it is really through an eco-friendly remediation approach that can help us generate these carbon offsets. So a lot of attention is being given to this. If you would please shift to the next slide. There is an awful lot of capital and talk and attention being given to this matter of orphaned wells, both nationally and internationally. And that is really what our focus was. This company was formed collaboratively about 1.5 years ago, and formally about 6-8 months ago, in really just having relationship ties to the oil and gas industry, and being able to connect a few like-minded individuals that saw this possibility to be able to take this situation that we have here with these orphan wells and really do some good things, not only for our environment, but also the industry at large. So we've got a passion to help really convert and help the employees within this industry see a new pathway to building into the industry a greener approach. So if you would please, next slide. So we are an ESG focused company though, so we have a woman-owned business as a part of all of this. Dawn Boyders, our co-founder, and we really are focused on the environmental and the social and the governance pieces. So hope to be able to deliver that to all of our clients as affiliates as well. So what's really a big impetus behind this effort is governmental funding being put into play. The orphan well situation is decades in the making, and we'll talk a little bit about what gets a well to being orphaned and explain a little bit on that. But nonetheless, there has been a shortage of capital that's been available at the state level to really address the matter of orphan wells in a dramatic way that we all believe we need to now with the methane issues. So just over this last year, the Biden administration did pass the infrastructure bill, and within that is $21 billion towards the reclamation of orphan and abandoned wells and mines. Within that is the ability for each of the states that have orphan wells on their reported list to go after these grant dollars that will support the effort of plugging these orphan wells. And currently, over the next 6 to 8 weeks, each state is going to be submitting their bids, if you will, for a $25 million grant that would be awarded to the state for projects that qualify for the mandates of the infrastructure bill and these dollars being allocated. Particularly, it's pretty vast. It's looking at emissions, it's looking at the reclamation, it's looking certainly at the plugging of the mine or the well. And what we see is an ability to really tie a lot of these pieces all together to make it a much more valuable dollar being invested into the states. And that's where I'm excited to have Barry joining us on this, because he is really in a position of steering some of these dollars, or at least providing industry input and guidance on where and how these dollars can best be utilized. So with that, Barry, if you'd be comfortable, maybe just sharing a little bit about what has you in the position that you're in right now, what your background has been up to this point, and how you see being able to affect some of these dollars on a state level in partnership with firms like ours and others.
Sure, absolutely, and welcome everyone, and thanks for your efforts in tagging in to pick up the initiatives that this team is pushing forward. To give you a little bit more of an insight with my background, I was a former Chevron guy, ran Chevron's environmental management company for the last handful of years there before going into the independent side of the business. And with that, spent time generating alternatives to the typical way that you plug wells, predominantly focused on minimizing the use of cement and looking at maybe a better plugging media. But what that also entailed was working hand in hand with the regulators across the various oil and gas producing states to understand what regs give them the ability to do, what it takes to get pilot programs in place, and ultimately what does it take to get some of these regs changed. So I have had a large part of my history in working with the plugging and abandonment of wells and reclaiming sites, and also the unfortunate part of handling some legacy issues when companies re-inherit old sites that either weren't plugged properly or come back through the food chain once they've divested assets, but they re-inherit them later down the road to have to plug and abandon at that point in time. Like Mark mentioned, the timeline is getting pretty tight, where most states were targeting around May the 13th to have their initial applications in for this initial $25 million bucket of funds, which at that point in time, the feds have roughly 30 days to fund the state. So that kind of puts them plus or minus the middle of June. And then states have another 90 days to actually get contracts out in place. So what we're seeing right now is that states are quickly trying to understand how to step up their game to actually spend and not lose the opportunity to use these dollars to help an ever increasing problem that everyone seems to understand that we have now, and especially in the state of Louisiana. So the state of Louisiana will be going from plus or minus a $10 to $11 million annual program to a $35 to $40 million 22-23 program. And so how do they step up their operations to be able to handle that is really been the question, and especially while the Department of Interior is still putting out guidelines on how to qualify for some of these dollars. Like Mark says, once we get past this next set, then really when you look at kind of methane monitoring and clean water initiatives really start to play a much larger part in states qualifying for additional funds. And all of the oil and gas producing states legislatures are really looking hard at their internal rules to see what legislation needs to be changed so that they can take in federal dollars without limiting or changing dramatically the way the state's programs are currently being run. And I'll give you a quick example for Louisiana. The current oil field site restoration program is funded by operators paying a small fee into the fund, but that fee caps out at $14 million. So obviously, if the feds put in $25 million, that cap would automatically be met. So one of the pending legislations is just to clarify that, look, this $25 million or new federal dollars will not apply to the oil field site restoration program caps. The other thing that really has been a challenge, and again, especially for Louisiana, the regs are fairly restrictive in really making the states consistently go out for what we will call turnkey bids on projects. So there's been some loose language that was added the last legislation period that allowed for a waiver away from that, but you still had to prove competitiveness in whatever approach you was going to take. And of course, the state coming up on what that was going to look like definitely hasn't made it to the next level yet. So one of the things that we're pushing for on the state is to really open up and look at much larger project management, partnering with groups that have the ability to not only just plug and abandon a well, but also equally be able to go out and measure for methane to help the state qualify for additional federal funds, also for site remediation. So again, there is a variety of things that the state's having to think through. And obviously, right now, it looks like the initial plugging funds that the state normally raises will continue to be managed with a turnkey hardcore bid process, and the federal funds is being looked at it being managed at a higher level project management process, which will be the first time the plug and abandonment for Louisiana has actually been able to do that. So what that looks like yet, I think we're all sitting and kind of anxious to see, but it definitely is a huge opportunity to run this piece of the business differently.
Yeah, no, I appreciate that, Barry. I think that's what the infrastructure dollars require. To Barry's point, it's this methane component, the measuring of it as well. And that presents an opportunity, actually. I think where OFX, our team, and as we're talking not only to Louisiana, but I'm here in Colorado. So we've been talking to the COGCC here as well. It's a big challenge. They know they have this opportunity. We all want to really make sure it gets utilized and optimized. And there's a big issue to address here. So there's an awful lot of wells. Just real quick, Barry, how many wells in Louisiana are on the Orphan list now? 16,000, somewhere in that ballpark?
Well, yes, it's just over 14,000. The one thing that it doesn't really address is the huge number of wells that are in very, very small mom and pop size companies' hands, with a small minority of those wells that are actually producers. So one of the catch-22 situations that the state has gotten into, obviously they realize forcing smaller operators' hands to aggressively abandon wells, they're scared to death that will force those smaller operators out and drive that number of orphan wells up. And, it's a status code 33, which is called shut-in future utility, which 99% of the time really means that's just a code that the operators will put so the state regulatory agencies doesn't trigger for a forced P&A. So of that, the majority of those wells are truly P&A candidates. So what we see is there's, and it's always, again, an interesting thing in the business. There never seems to be a perfect time for an operator to P&A well. So when you've got $100 oil, all your dollars is going to generate additional production and grow your reserve base. And of course, when when you've got a sub-market or low price environment, everyone's pinching pennies trying to keep the lights turned on. So it just never seems to be a sweet spot. Now, interesting, if you go to the federal waters, magically you really don't see that problem because it's a much more aggressive mandate that the feds use with operators in the federal waters, whereas that same level and the different level of size companies that has a majority of the wells, it's just a total different operating environment that we're faced with.
Yeah, yeah.
So
Let's, Barry, if I may, let's just touch on what it means to take a well into an orphan status. So we've got a slide here for everybody, just to kind of see the steps. And ultimately what we want to walk through is get into some of the things on this point Barry made about more of a general contractor and how we really see being able to utilize biochar in a couple of different components of this overall process, but it incorporates the methane measurement as well and an overall reporting. But an interesting note is really how a well gets to be an orphaned well. And it's been a challenging environment over the last many years as we have these boom and bust environments. Ultimately, there are wells that no longer are productive, as Barry was alluding to, and the operator, if in good standing, has this ability to really just shut them in and just kind of postpone that plugging until they can afford to, or other matters. And that is a big reason why there's a large inventory currently, is that oftentimes, because of the nature of the commodity cycle, you'll see here too often wells that are shut in become abandoned because, unfortunately, an operator might be in good standing today. We go through this $100 oil cycle that we're in right now. They may have bought new assets, put new wells into play that are economically viable at $100 oil, but then it goes to $40 oil because something else happens. And an operator might be struggling to maintain their ability to be profitable, and they may have an inventory of these shut-in wells, and if they have to go into bankruptcy because they can't afford to keep operations going, that's where the state now takes possession of that well, because there is no longer a responsible party overseeing the management of that well. And hence, we've got an abandoned well now. So that's what these states are putting on these lists. And part of what we see in this approach, as Barry identified, yeah, we've got these operators where there's a lot of wells that are on the shut-in list of theirs. They just haven't been able to get to them yet. And what we see is an opportunity to demonstrate through new methodologies a way to actually capture methane emissions and monetize some of those that would help the states and the operators continue to fund up the plugging of these particular wells. So if you would please forward the slide.
And Mark, I will add one point that really is common sense if folks think about it. Normally, wells, when they change ownership hands, the wells never move up to a larger operator. So usually the wells in sales processes always continue to move further and further down the ladder to smaller operators, which put the wells just by default more at risk.
Absolutely, great point. Yeah, and that is, it's a very big issue and a challenge that we all, as an industry and as a community that has that industry in our backyards, it's a challenge. And there are changes that are occurring in various states that are potentially helping those smaller operators, and then others that, if not handled properly, like these regs, could inadvertently turn a lot more of those companies into a non-profitable entity, and therefore just add a lot more wells to the orphan list. We think with the proper approach, we can help operators economically plug those wells anytime. And that is a big goal of what we're doing. The biochar is another very important component of that as well. But we do think these dollars that are coming at us now, these are all of our dollars. These are dollars we've paid as taxpayers to go in. And while we certainly, many of us have challenges with the industry and how funding towards taking care of these matters has been handled, that's not what we can change. We can change what we're doing moving forward. And that's really our goal in this. So next slide, please. When we take on a project, if you can envision a square, and let's just say that square is a square mile, it's called a section. Many times there could be dozens and dozens of wells within that square mile. Many times there's only 1 or 8, just depends on the size of the well and the formation that it's going after. But the surface area around each one of those well bores is always being utilized in some form or fashion to some degree. From putting the tank batteries, the big tanks that you see when you're driving down the road next to the pump jacks that are containing the oil, and the gathering systems and everything else that go from that wellhead to those tank batteries and beyond, there is the potential for surface contamination in a number of these different areas that the operations occur. What we love about biochar is that it can really accomplish a number of different things in going towards circularity for the communities within which we operate and where there are oil and gas operations at large. And what we mean by that is just like here in Weld County, as a simple example, we have hundreds and hundreds of acres that are affected by beetle kill pine. And it's a big problem from a fire hazard. And if we can pull that wood out, which we know the Fish and Wildlife and Forestry Service, a number of different initiatives are going at that. Well, we've got that waste wood. What do we do with it? Well, if we can help by utilizing the end product of that wood being harvested and put through the pyrolysis process, and now we've got that biomass turned into carbon, we've eliminated the fire risk, we've eliminated that waste problem, that waste stream. We've created a carbon product that can be used in the remediation of these well sites, because biochar is shown to be a fabulous remediating material for all kinds of ines and enes and byproducts that come out of the production of oil and gas. And in doing that, okay, we've just solved one problem before we've even gotten to the well site. Now we can clean up that well site in a much better way, we think, by really helping the soil be returned to a state that is its original state and with a healthier biome. So we can help eliminate those waste issues. We can help companies eliminate their waste disposal fees if they have wood pallets, things of that nature. We see a number of different ways of incorporating biochar manufacturing into the overall circularity of our process. Next slide, please. What we see in that process is it is very much circular. So I've kind of hit on a few of these points already, so we won't go too far on it, but we do absolutely expect that biochar is a big part in the remediation of the surface areas. And that extends into mines as well. We've got some ideas about that. And other ways that we can utilize biochar in the upstream applications of oil and gas, whether that's pipelines and really creating easements that are potentially carbon sinks because we turn them into some type of an estuary or conservation lands, where that whole 100-mile line of pipeline could have remediated soils with biochar, where we have a carbon sink in that effort. And then we could potentially put in monitoring systems all throughout that acreage to see if we're actually gaining further carbon sink benefit over time through the restoration of the natives and grasslands in those areas. Next slide, please. As it relates to decarbonizing the industry of oil and gas, there are a number of different ways to go about doing this, we see. So we just touched on where the remediation of the soil area around these well sites is a wonderful application for biochar in what it can do for the reclamation of that surface. Barry, I'll touch a little bit on how challenging it is for the industry to make operational changes that can really reduce the carbon intensity of an operation. One of those areas that we have been focused on initially is in the wellbore. That there are ways to utilize different aspects of these wells that we're plugging in order to sink carbon. And if you would forward to the next slide. And in utilizing a different approach that's a little bit more open-minded to what materials can be utilized in a wellbore, how to utilize the space in a wellbore, and the types of materials that we use that are carbon intense, that we can offset or displace cement, as Barry was alluding to. So we have a plug design that we won't go too much into, but we see an opportunity very much so to sink a lot of carbon in these spaces, along with the areas around the wellbore. And then there's other applications where we see biochar being applied that can really reduce the carbon intensity of those operations even further. But Barry, do you mind touching on this challenge of carbon intensity in oil and gas operations, and your experience utilizing different materials and getting those materials approved by various states in your background? Can you just touch a little bit on what you see with this opportunity?
Absolutely, and I think it may be jumping the gun, maybe one slide, but one thing that needs to understand is just the process of creating cement is one of the most intensive carbon processes out there. So anything that we can do to limit the physical amount of cement is a plus, right? And now what we do, if you look at the oil and gas regs, really you have two components, one of which is much more sensitive to the regulatory agencies, which is the cement plugs that either go across the perforations, across USDW zones, or for the top surface plugs. Those seem to be really more focused upon and a little bit more sensitive to have regulators consider other ways to do it. And then what my history has shown is the area between the cement plugs, which we call spacers or voids, is typically some liquid form, basically a weighted water. Some agencies will mandate it. You put a little corrosion inhibitor. But from a regulatory perspective, there's very, very little pushback to be able to basically mix biochar in with this fluid media, and with the same process circulate this down between the well locations. Another issue, and Mark, one that we really haven't talked about, is really the next generation of equipment that could be used to eliminate some of the air emissions, since almost everything out there is all diesel powered equipment. But I do think that will continue to be one more item further down the road.
Great point. Yeah, absolutely.
But, obviously some of the work that can be done is additional lab work that gives us documentation to be able to prove to the regulatory agencies by having a certain percent biochar additive put into a typical cement could reduce, your cement volume down, what, Mark, 10 to 20% without having any significant decrease in the performance of that cement. Then, of course, you will hear me later on say there are other, equally as good components as cement, and especially when you get to some past history that Chevron has had utilizing compressed sodium bentonite in lieu of typical cement plugs. But again, that would be something else that it would be very easy to be able to mix biochar in as well.
Yeah, no, those are all great points. Great points. I think we can forward to, yeah, the next slide, because we can touch on, there's a new methodology that's coming to market, and this is a critical piece to, again, what Barry is speaking to in the overall view, that these states are going to be expecting not just the wells to get plugged, but to really get some insight. We need to understand, okay, we've got, I think 6,000 wells that are on the list here in Colorado. Of those, yeah, we don't really have any good insight on what the emission rates are on those wells. So interestingly, over the last year, and really the beginning of all this is started with, you got to throw a shout out to Curtis Shuck and the Well Done Foundation. Don Boyder and I, as we were both on our own individual paths, we came across Curtis plugging wells up in Montana and using the emissions that they've measured, and working with American Carbon Registry have been putting together a methodology to monetize the emissions avoided once you plug a well that has been measured and accurately and completely plugged, stopping those emissions. So this, we think, is a really interesting component to the overall approach that we believe makes the most sense. And that is, as we go to help plug these orphan wells, or even on the commercial side, if we have a company that has a package of 50 wells that need to be plugged, we can make an initial assessment of those 50 wells, which count for additionality. So the whole carbon market, and this may be a conversation for another time, but the ways to qualify for carbon offsets can be pretty complicated. And the methodology is a critical component to that. Additionality is just as important, that we are genuinely doing something different that isn't required or in the course of normal business to generate these carbon reductions. Well, ACR has been down the path with public review. They've got scientific review that's back in, and my understanding is by the end of this year, they'll have a methodology that would be allowed for us to measure these emissions from these orphan wells and shut-in wells prior to plugging, assessing what that emissions rate is, and potentially achieve an avoidance offset value from going through that measurement and plugging process. Well, that volume is of concern to all of us, and certainly methane emissions are the priority, it feels, from the most recent IPCC report. Methane emissions are where we can have the most impact most quickly. So for our ability to go out and help really the states in terms of the dollars that would be available to plug more wells, or individual operators, frankly, that would have an ability to really increase and accelerate their plugging programs by generating offsets from the measurement of and avoidance of the emissions from these shut-in wells and orphan wells, we think is an important component to pushing all of these initiatives forward. Barry, do you have anything to touch on that component right there? Anything I may need to clarify or clean up?
I think you did a very good job on that, Mark.
Okay, thank you, sir. Appreciate that. So this is coming about. It's a very exciting and beneficial attribute to we think the industry adopting new protocols and really having an ability to affect the shut-in well inventory that they may have, and prevent ultimately then any of those potentially going to an orphan status. So that's one component of carbon intensity reduction. It's one way to utilize the emerging carbon offset markets to help subsidize the cost of plugging these wells. And that is potentially needed in many of these instances. The offsets created by utilizing carbon removal technologies are another really important part. That's the carbon sink, but displacement is also a very important part. And Barry just hit on that. So as we see these plug jobs being mandated, where from the bottom of the hole all the way to the surface, you need to use Portland cement. We can argue, and have argued successfully in Louisiana, that no, we could actually utilize a different material in that spacer and make that a carbon rich sink, but more importantly, displace or avoid the use of 12 tons of cement, maybe we only need 2. So every ton of cement roughly is 1 ton of CO2e. So we can be potentially displacing and avoiding on many of these wells, depending on the jurisdiction, an awful lot of an awful lot of CO2 that would have been emitted, and by utilizing less cement, we're able to avoid that by displacement. The last piece is that carbon sink, where in the remediation of the surface area, meeting certain criteria of the various verifying bodies is how we get to a point where you can actually monetize a carbon sink. That's all early days, but we see a pathway for that, and we know there's more and more verifying bodies that are understanding the benefits of carbon through biochar, and we think that market will pick up quite a bit here over the next 12 to 24 months.
Hey, Mark.
Yes, sir.
If I may, just for any of the operationally minded folks that's on the call as well, operationally, there's no additional equipment needed that would be different for utilizing biochar than it would cement and pumping fluids in the well. So, what we're basically are talking about is just using better materials to end up with a better job.
Absolutely. No, that's a very, very important point, that we don't expect the operating entities to make big operational changes to their protocols. And that's part of what these pilot programs that we've been doing. It's really just working out the SOPs, standard operating procedures, how to integrate it seamlessly. So it isn't a big lift. That's a great point, Barry. Thank you.
Well, and again, very, very easy for work crews to understand, and it's not a lot of additional training needed, less just really changing the materials that's being used.
That's absolutely right. Yeah. So we're working on, to Kathleen's point at the beginning, we're working on all those logistical components, tying all the pieces together to really create this ecosystem that we have. And it allows us to be in a position for these states, we believe, and operators at large, for us to really general contract this overall carbon reduced plugging approach, where we go in and we measure those emissions to begin with, see if there are any that are emitting in meaningful quantities, design new plugs that can minimize the amount of CO2 being emitted in the process, so displacing that cement, and then finding ways to utilize the project for sinking carbon through amending soils or other aspects of that. So with it, by the time we get through that whole process, we can report back to the operating company or the state, here's what we've avoided, here's what we were able to sink, and take a look at the rejuvenated landscape that we've just produced, because Dawn's family and her passion is certainly getting these areas where they are not going to be returned to agricultural use really back to a estuary type state where we've got pollinators and natural grasses that are growing and really helping return those soils back to a good healthy state. With that, last slide, and I think that kind of sums it all up. Ultimately, we think there's an awful lot of work to be done, frankly, and the attention is being given to it. The dollars are being allocated as needed. Opportunities to do this more economically viable, and certainly to really affect operational protocols to reduce the carbon intensity of these efforts. We think it's all doable, and biochar is a big component of that, we see. So with that, Kathleen, I think if there are questions out there, we'll kind of lean into those and see what we can help out with.
All right, thanks very much, Mark and Barry. It's an exciting new area for biochar, isn't it? Before we jump to questions, you and I have talked about this Adopt a Well program. I know it's early days, but I thought you might want to, provide a little detail on that.
Well, excuse me. There are, a couple of different ways to go about this. So I'll give another plug out to the Well Done Foundation. They are a 501c3 that's set up for foundational charitable contributions, and they do utilize those contributions to go find high emitting wells and stop the high emitters first and foremost. So they're a interesting entity that's doing some great work, and certainly was part of the inspiration for us being in the carbon removal space in the oil and gas industry. To your point about adopting a well, if you will, that's a term that they use, but it's certainly an accurate term. We are working with a couple of different environmental groups and agencies, and are, in a sense, effectively, they have capital that they would like to deploy towards this effort to glean further insight. There are a lot of different R&D projects that we have circled that we'd like to explore. And each one of these opportunities to plug an orphan well gives us an opportunity to learn more about protocols and benefits of biochar. So we've got long-term studies from a remediation perspective in mind. How does the biochar, if in around the wellbore, capture any potential escaping gases within the annular, or any other voids that we may have missed in the plugging of that job? Are there benefits of having like a prophylactic over the top of the wellbore that it might capture those stranded emissions that are just slowly seeking up? So there's a lot of different R&D with an adoption of a well, if you will. It's really just a term for collaborating with other parties to really help fund the project of plugging a particular well and gleaning some good insight from it.
Great. Okay, so I'm going to go to some of the questions that have been coming in. First off, Amy says, thank you for sharing this information. Have you looked at the use of biochar in preparation of well pads or tank batteries as a proactive spill barrier, or the addition of biochar to backfill on pipeline right of way?
Yes and yes. Yeah, you're thinking the right way, Amy. That's great. Absolutely. So we see a number of different ways to, again, it's just a protective measure, really. It is so good at helping us on the reclamation and remediation of these sites. So we think there is an opportunity to sink as well as do good in both of those applications. And the pipelines, as we were discussing too. So that lay lots of opportunity.
Yeah, agreed. A question on whether biochar can be used to solve oil spillage, and I'll give you a little insight of what I did today. I had to dispose of some mineral oil, and I asked my contractor what he would do, and I didn't like his response, so I simply filled it up with biochar, and then I feel better about disposing of it. You probably have a more technical answer.
To be perfectly frank, we have not explored the multitude of applications that could be explored in utilizing biochar. We do know that there is a lot of potential in that regard. How to effectively do it? Are there combinations of materials? So I come from the hemp industry as well, and we see hemp hurd as being quite the remediating property, and we've had conversations with experts that a combination of the two might be a really good application. So it is an area that's worthy of further research and thinking through how best to apply it, and where do you go with it after it's done its job is another
down
challenge.
The well hole, I think.
That's where it seems most sense to us, for sure. So yeah, we've definitely talked about ways that, you know, charged biochar, if you will, the various biochar applications that might be loading up on metals or other contaminants that would be problematic in a landfill. We certainly see there's potential for the disposal of those used biochar, that biochar in the application in these wells, because it could be sequestering it in such a good way. Now, there's water table issues. There's a lot of challenges with that, transporting hazardous materials, etc. But it's interesting. Yep.
Yes, indeed. Okay, John in South Africa is asking about something that was on slide number 3, showing a swamp with a sign showing 1902. I'm unfamiliar with the term wellbore, assuming that it's the hole that has been drilled into the gas-bearing strata or sand. What stops the gas simply migrating through the soil to the surface when it can't egress through a plugged hole? Did that make sense?
It did to me. Barry, did you track that? And is that something you want to?
I
Just kind
can, and I will take it from 2 different sides. If the question is referring to outside the hole in the ground that was dug, it's actually a function of the geology, the way the Earth's made between sand packages and hard shell layers that separates those packages that prevents the migration all the way from any potential productive source or sand further down the wellbore. That's what prevents it from coming totally out to surface. Of course, inside the hole that is drilled itself, then that is the combination of where cement plugs or mechanical plugs are being used. And then we would incorporate this spacer material between those plugs and even potentially cap the well with biochar afterwards that would help contain that inside the wellbore from then on.
Yeah, great answer. I think that's the question. That's
Yeah.
how I heard the question too. Yeah.
Okay. Amy has a couple more questions here. It seems like the quality of biochar used in plugging wells and potentially other applications could be lowered from IBI specification for PAHs and other compounds. For instance, the limit for benzene could be a little higher without impact to the environment. So I'll take that one because I don't know how familiar you are yet, Mark, with the IBI standards. I would tend to agree with that, although we don't yet know what it would be. It's certainly something that should be looked at in the very near future if this becomes a thing. But I would assume it would be a bit like the European biochar standards, which have 4 different categories right now, and the 4th is a materials use in different composites kind of standard, and that's exactly how they set up their different standards. Is that one is a little bit less strict than biochar is used in soils and animal feed. And then she had a question which I'm not sure I understand. Has anyone looked at biochar as a proponent in fracs? Would that be fracking?
Generally speaking, when fracking is done, the water used to fracture the geologic formation does come back out. So that flowback water and the reclamation of that flowback water is being explored aggressively. Yes. There are some companies that are doing some post-manufacturing processes to their biochar that are targeting some of the more tricky byproducts in that flowback water. But yes, there are waste streams from the fracking of wells that we see as a potential place where biochar can do some real good in getting that water to be reused. Nitrates in particular.
My friend Harry Groot has a question on if you're using pure cement or are you using grout or concrete. What's the percentage of cement in the grout or concrete, and how much of that are you planning to displace with biochar? Are you planning to also use stuff the bore with the biochar? Sorry, this question to serve as a sink, which I think you addressed the latter part.
Yeah, I think that's a fair statement. Yes. The first piece, I'll take a go at it, Barry, if you want to clean it up a little bit. The American Petroleum Institute is really in a way, an unofficial governing body for different materials and processes that are used in all aspects of oil and gas development. And with it, there is a very specific API standard too and what is used in the cementing of well bores, depending on the depth, pressures, and heat. But there are, I think, 7 types of Portland that are approved, Barry, and more commonly, it is a cement, not a concrete. There's but there is often amendments to that cement for lost circulation material. We've actually toyed around with hemp hurd as lost circulation material. It's kind of a woody product or some kind of it really acts as a rebar in the cement if there's a larger hole and the cement isn't stopping or plugging up that hole. So my point in all that is the API has certain ASTM standards for compression strength and things of that nature. And what we have to be able to adhere to are those API requirements and the ASTM standards for compression strength. So we are in a dialogue and kind of working through that process of testing to those API standards in the hopes that we might be able to displace upwards of 8% or so of the cement. To your question, how much? We know there's enough bench samples and studies related to construction that past 8%, we might not be able to hit the compression strength numbers that are required. Barry, do you want to add anything more to how challenging cement is and working with it relative to?
No, I think you did a good I think you did a good summary of it. I think obviously the answer is you want to be able to displace as much as possible and still meet the performance standards that are required. Likewise, to the point of how much do you want to put in that void area between plugs? Obviously, likewise, you'd like to get as much material mixed in so that you can still handle the solid content and still pump it down to the desired location.
Yep. Yeah, great answer.
Great. So question on what would be the estimate of tonnage of biochar to be used in an actual well itself and the area around the well for remediation? A range would be helpful. Also, what are the biochar characteristics that would be preferable in these applications?
Yeah, what we have come up with initially is a range. Every well bore is different in its design and how you plug it, etc. The surface areas as well. But the general range that we are expecting isn't going to move the needle individually. It's about 1 to 4 tons of biochar per. You get into some of these bigger wells. We are predominantly focused on the wells that have been orphaned. And those, by the history of the oil and gas industry and technologies being advanced, those early day wells are typically no deeper than like 5,000 feet. So we're focusing on these shallower wells where there's just not a lot of volumetrics to work with. So the surface area adds a lot to that in terms of biochar usage and in the potential of carbon offsets being created. I think that was there another part to that question? I think.
About the characteristics of the biochar.
Optimal biochar. No, there isn't at the moment. In theory, for every one of these sites that we want to have as much carbon going into it as possible from a carbon offset perspective. So that's kind of a driver, but at the same time, the biochar has to be manufactured in such a way. So meeting those criteria is a big driver in what sources of biochar might be applicable. From a remediation perspective, I'm sure there are particular areas and types of hydrocarbons being produced depending on the geology that maybe one type of a biochar might have better attributes for the particular geologic formation that's being produced and its residual surface area contaminants. But generally, biochar is biochar in that regard, in that it's a pretty broad scope of things that we're trying to clean up.
Right. Which lends itself well to the fact that you'd be capping these all over the place, so you don't have to import from far away a biochar.
Really important issue. Yeah, back to the circularity of all this. Ideally, what we'd hope to be doing is either in the business of or partnering closely with biochar manufacturers that are geographically close to our areas of operation, because that transportation cost makes it prohibitive for sure, let alone the LCA and what that does to that. So the life cycle assessment.
Great. So this is from my friend David Derbauka up in Canada, and I'm not sure I totally understand it, but it may be an industry thing. So let's see if you understand it. Does rust compromise a casing? So do we seal things off outside and inside a given casing?
Barry?
That is actually an excellent question, which was one of the primary drivers that while at Chevron, we looked at various other alternatives other than cement, because once cement is set, it's very, very rigid and there is no pliability or expansion of the plug. So obviously with the groundwater saturation, you continue to have casings erode over years, less worth hundreds of years. So it was always a concern, how are you not creating a future flow path once the casings eventually totally erode? So again, I do think that is a very, very excellent, excellent question. And as more and more research is done on biochar and its ability to kind of reform and have a little bit more pliability, it's going to be, in my opinion, a question, can we continue to use it maybe in conjunction with things like very high density bentonite or different things where, unlike cement, once the conditions down to wellbore change, you still have a plug that continue to change and adapt to its new surroundings, if that makes sense.
Mm-hmm. Yep.
Yeah, great answer.
So
yeah,
here's another one. I will say that David, that question was asked by David, and he is an environmental engineer, and I think it might be useful if I introduce you to each other, because he's been doing a lot of remediation with biochar over the years.
Oh, that's great.
Thank you, David. Yeah.
Yeah, I love that.
Another question is, if you're able to monetize all the benefits for using biochar in this application, what is the value of the biochar to those paying for well capping?
That's the $1 million question right there. It's been one of the bigger pieces to the puzzle, frankly. As with ag applications of biochar, we know there's fabulous benefits, but these are all for-profit industries that we're targeting. So one of the bigger challenges is how to make the ancillary benefits, how can we account for them and put a monetary value to them? That's an exercise that we've been working on more diligently just over these last couple of weeks, because as you look at the cost of biochar in the marketplace right now, Kathleen, I think I heard you not too long ago, is somewhere around $500 a ton. Mm-hmm. And you know, by comparison, I guess I'll just leave it at this, and everybody can kind of noodle on it themselves in a way. But if we're displacing cement as an example, ideally what we want to be able to share to an operator who's having to pay for that plug, that the cost of this other material isn't any more than the cement that we displaced. Well, cement's at about 9 cents a pound, and we're not quite there on biochar. We're at 2-3 times that, right? So the other benefits are critical, and that's where that relationship and the process utilized in creating the biochar, the feedstock that's used for that biochar production, the regional location geographically, all of those are factors that are impacting the economics of utilizing this approach. And thankfully, there's enough carbon markets in place now utilizing biochar and have methodologies around them that industry or that segment of the biochar industry, I think, will grow pretty dramatically over the next year or two. And that's an important part. The carbon financing of the char itself is a pretty important factor in all of it.
Agreed. I would also add that there, I believe at the federal level, is now an executive order for preferential purchasing of low embodied or carbon sequestering materials. So you may be able to leverage that in some way in the near future.
Well, full circle back to Barry's point that these Fed dollars on the state level are being looked at in terms of how they're being awarded a little bit differently. And that's where we expect to be leaning into all of those various aspects, because what we are doing as we approach this traditional activity in the oil and gas industry is, okay, we're doing it with a little bit more carbon sensitive bent, and in doing that, it's valuable. And there are these various attributes. What does that mean? If you are an operator that's going out and just buying a carbon offset on the market to reduce your carbon intensity, shouldn't the operator that's actually initiating an operational change benefit more from that effort? And shouldn't that carbon reduction be worth more, optically at the very least, right? So all those components, I think, are important in determining how to scale it.
So Peter in Nigeria may have asked my favorite question so far. He said, we have lots of abandoned and orphaned oil wells in Nigeria. How do we partner to implement your solution immediately?
Hop on a call as soon as we can. Very good question. We'd love to have the dialogue. I think it's a function of what resources are available locally. And Barry, I think you did international. I know you've done international work, so I'm not sure what that requires from an operational perspective, being in a completely different jurisdiction, but.
I do think that, again, excellent question coming from Nigeria. They do actually have the scope of wells that would probably make it economic to actually grow a full support system to really go all the way from the pre-planning all the way through the execution. So I do think through a partnership, Mark, we could be able to meet any need they would have there in Nigeria for this.
Yeah, very exciting. Yeah. Love the question. Thank you.
Rob is asking, is the biochar used a proprietary formula or can we make our own?
Here's the rub on that one is, can you get your own certified? Because in order to help with the economics, you're going to want to be able to monetize the carbon offset. So, I mean, there may be other ways to do that, of course, but the short answer is no. Biochar, being biochar, is carbon, and the ability to put carbon in and offset the carbon being emitted in the process is the real goal, to get to a carbon neutral plug job. So can you do that in accounting with that company that's engaging you? I think that's possible, yes.
Yeah, it's all about economics.
Yep.
Is there a temperature or pressure associated with an orphaned well? Oh, no, sorry, what are the temperatures and pressures associated with an orphaned well? I assume that means when you're plugging it and pushing down biochar.
Yeah, I'll defer to Barry on that one.
It literally is really by operational area. You tend to have some areas that literally are extremely low pressure, low temperature. You end up with other areas that have much deeper wells, much higher pressures, much higher temperatures. So I would say it's both a function of geologically where that well's located, as well as geographically. Some areas tend to have deeper wells versus shallower wells. It's really a well by well kind of look, or at least a field by field difference.
Yeah. What we're running into in the wells that we're targeting, and typically these 5,000 foot or shallower wells are not so pressured. Typically, again, just as a blanket statement, that's not something that we're running into. Certainly, the temperatures and pressures are not an issue for how we're approaching it. Certain formations are a little more pressured. So, like up here in Colorado, we'll have some of those issues, but those aren't unusual to traditional plugging and abandonment operations.
Mm-hmm.
Biochar would handle that regardless.
Just to clarify, one of the things somebody asked about certified by whom, and I think in this case you mean by one of the carbon removal marketplaces, so either Puro or Carbon Future, and in the future Vera or VCS. Is that right?
That's my understanding currently. Yes, ma'am.
Okay. This I think is a good clarifying question. There seems to be a very clear limit on how much methane char in the wellbore could absorb before becoming saturated. That's not really what the purpose of the biochar is for on the absorption side, correct?
Yeah, it's a really good question. It's a desire of ours to actually put monitoring systems in place in some of these pilot wells we're going to be doing to see if indeed there is any absorptive aspect of that biochar within the wellbore. The predominant, this might be a little controversial, but well plugs generally, when they're freshly done, they do plug emissions. They do stop those emissions. So if you've got a good plug job downhole, and then you got another good top plug, there really shouldn't be any methane escaping. And therefore, the biochar in these wells isn't so much the adsorption capabilities of it. It is a function of the carbon sink. We do think that a particular amount of biochar in the cement does make it a more malleable plug and a better plug in that regard. And we do believe it will still maintain its integrity per specs. So we do envision going after that because it should be just a better plug. Geology moves. As it moves, it may crack traditional Portland cement. We think biochar infused cement is going to be better to help address that. And then there's other corrective materials that we can put in there that are self-healing that we want to toy around with too. So, but yeah, general point of it's carbon sink, but we are interested to see if it does help. And Barry alluded to it earlier as well. Once you typically have to dig down about 5-6 feet from the surface area, cut off the casing, and then put a metal plate. You seal it up there, and then you cement it, and then you put a metal plate on top of that. We do see being able to sink more carbon in that area, and that we think could also act as a prophylactic, if you will, that if there is any emissions that is occurring and migrating up, that might provide some kind of a protective barrier.
Yeah, more questions about the type of biochar you're using and if there's a preferred temperature range that it's produced at. I think the jury's still out on that one.
Agreed. Yeah. High carbon, ideally.
Yeah. And then a question on whether wells serving as garbage dumps get cleaned out.
That's a great question. That's somebody who knows the industry to a degree.
That's my friend David Durbowka again.
Barry, what's your take on that? We do a lot of fishing before we plug them, right?
Well, yeah, and you got to think, so the industry's already went through a couple of very similar exercises like this. And if you think back to when NORM, naturally occurring radioactive material, really became a hot topic, no pun intended, there was a lot of efforts of disposing of NORM and contaminated metals, mainly tubulars, back down inside of wellbores. So we really had a history of probably 10 plus years that we were already doing this with other type stuff to take care of issues that the industry was having down some of these idle well bores that were being plugged. But conversely, absolutely, if you want more room to put more biochar into the well bore, then obviously it's a function of economics. The more time you spend cleaning out the well bore, the more money you're going to spend, right?
Right. He also asked about whether accurate records exist for all these orphaned wells.
Oh, that may be one of the best questions of the day.
Exactly.
It is accurate records are relative to the operator that had it before it going to the next operator. So what we'll see is you will have very accurate records of wells while they were in their infancy or up to 20 years of life. But the longer of life they have, and the more and more operators that they go through, and the smaller operators that they go through, the records become less and less. So literally by the time that the wells go in the orphan program, you get to do what we call a lot of exploratory surgery, and that you literally don't have a lot of confidence in what you're going to run into when you go into those well bores.
Yeah. Plus, just where some of these wells are. There's in Pennsylvania in particular, there's just hundreds and hundreds, thousands of wells that are just pre-record requirement. So there's well bores out there just emitting that have been there for 100+ years and nobody even knows about. Overgrown. It's a real problem in certain areas for sure.
And Mark, very similarly, you've also got fields that had so many well bores that have been there so long. When you use the surveying numbers that's calling well A, well A may only be 100 feet from well C. So other than know it's going to be one of these 5 or 6 wells, you got a lot of cases where the well could be any of a half dozen wells.
It's unbelievable. Yeah. So lots of work for all of us to dig into.
And I think the good news is they have dedicated satellites now that are tracking methane. And through that, I think we will be able to discover some of these untracked.
Oh, yeah, no, that's a great point, Kathleen. Yeah, we're in dialogue right now with an aerial survey company, and it's just a function of putting the right equipment on their drone, and we'll be able to implement a surface area surveillance of particular areas and see if we can't identify some of those super emitters and target those first. So yeah, there's a lot of great technology that can help us out with that. Just some form of magnetic device on that drone can help identify metal objects that could lead to, oh yeah, there's a well bore. Or here's another whole issue that's quite problematic, and it's hard to really identify as well. There isn't really the records and mapping of the gathering lines. So from one well bore to a tank battery, and the connectivity from multiple well bores to that tank battery, oftentimes those get lost. So you've got crude filled pipeline, what, a foot, 2 feet below surface, sometimes 6 inches below surface, just been covered up by soil. That is there as an environmental issue that we need to address. It's just how do we find it all? It's there's a lot of aspects of this that get pretty challenging.
Yeah. A couple of final questions. Will the LCA of the biochar be considered when it comes to deciding which biochar to use? And I assume that's related to, both the carbon content and the sort of carbon efficiency of production.
Yeah, I would defer to those verifying bodies. The methodologies that they require of the biochar manufacturers are very much depending on the life cycle assessment, where that source material is coming from, how far away from the facility, et cetera. And my understanding, although limited relative to Kathleen and others, is that LCA stops at the warehouse door after the processing has been done. Here's this biochar ready to be shipped. And then we'd pick up the LCA from that point forward.
Mm-hmm. That's a good idea. Question on whether you might comment on decommissioning pipelines. Is there a role for biochar there too? And you may just want to explain what decommissioning pipelines are for those like me, not in the industry.
I'll defer to Barry on that, if that's okay, Barry.
Absolutely. Interesting. You'll end up, pipelines will fall into two different buckets. Basically, lines that'll have very long line segments that can be permanently abandoned with that line remaining in place. Normally, that line will be flushed. So there is an opportunity there for those lines that will continue to be buried in place. There's an opportunity there to flush that line with that same biochar spacer material that we were using in the well bore, so you could literally have miles of material put in place. Also, at the ends, at each end of the pipeline, similarly to what the wells are done, you do excavate down a certain depth, usually 5 to 7 feet down below ground level, and calc and tag those ends. So there's also an opportunity to add additional biochar there for the natural healing of the ground area, where you could have some potential staining from pigging stations or other places where pipelines or wellheads were prior located at. So absolutely, you could get some substantial volumes that, of course, will be directly proportional to the diameter and the length of the line.
Yeah, no, that's great. That's great insight. Great question. Yeah, there's a whole, Barry's down in southern Louisiana and operates in the shallower waters, and that whole area, all throughout the Gulf, frankly. There are an awful lot of issues there that we struggle with as an industry, and how to address it, the remediation of it. And as Barry's identifying here, that's just one of the things that we can see that might work in that. But you get underwater, it gets to be a whole nother animal. But it's one that needs to be addressed too. So we're working on that as well.
Yeah, that leads into one of the last questions. Are you both looking to do work in European wells, such as those in the North Sea, or do you know of similar initiatives in this region?
We have some dialogue with an offshore entity, very early days, but I don't know much more than that, Barry. I don't know what is, if anything, is being looked at, and how the infrastructure bill is addressing the offshore wells, and certainly I'm not sure how the European offshore operations might look at it.
And I have no experience with that either, Mark.
Yeah, okay. Sorry. Got stumped.
I'll connect you all. We're going to have to wind down here, so I'm going to take one more question, which is, do you know if anyone is looking at a national stockpile of biochar as an emergency spill response inventory? Interesting.
Yeah, very interesting. I am not aware of that. But that's an interesting idea.
Yes, we should be whispering in somebody's ear. And now that the Biden administration has decided they're going to open up more drilling to ease the European situation, you know, maybe we can suggest those kinds of additional environmental requirements. So, and one last comment by Rob in Vermont. I think we should all get used to the idea that the market price for carbon removal will fluctuate down as well as up. Supply and demand. I agree with that.
Totally agree.
Yeah. All right. Well, thanks everyone for all those questions. That I think they were answered, all of them, which doesn't usually happen. Caroline, great, thanks. Just to let you know, our next webinar is actually coming up pretty quick. And that's mostly because our main presenter, Nadav Zev from Israel, really is a Star Wars fan, so he wanted it to be on May the 4th. So anyway, he's going to be talking to us about his operation in Israel, where they use biochar and compost as a soilless growing media. So, you know, we need to be doing everything we can to displace things like peat, and I think this is a good part of that story. And then Wendy Lou and I are working on having a more complete webinar series schedule this week, so hopefully that will be coming out. And as another reminder, if you haven't started listening to our podcast series featuring Akio Enders and some of our business sponsors that are in the biochar production technology business, that's a new service available for members. The first episode, episode 0, which just talks about pyrolysis in general, is free to everybody. And then we've noted a couple of related upcoming events. Most importantly, the next USBI conference is going to be held in Morgantown, West Virginia. The website for that should be up very, very soon, as well as the call for abstracts. So I hope to see many of you there. Next slide. And as usual, if anybody joined us not as a member and would like to convert to becoming a member and accessing all of our other webinars, you can do that for only $40 through the end of this month, and you can contact our executive administrator, Brian Shore, to do that. With that, I'm going to close up everything and thank our speakers once again for this excellent new market that you're pursuing. Really appreciate it.
We appreciate it, Kathleen. Thank you.
Yep. Take care,
Thank you,
everybody.
everybody. Thank you, Barry.
Thanks, guys.
Thank you, everybody. Yep. Have a great day.